how would the AI actually make things easier or more complex or faster? What do you envision there?
Yeah. Yeah. It's always fun to kind of like, hey, what would 2025 2030, it's like going to Disney in a we're little, right? There's like this futuristic, right?
Sure, why
Like
not?
Florida, Disneyland, right? They're like,
Well, here's the reason for asking
fly
this
and
question. The reason is, hello everyone. Welcome to one of our first episodes in Looking Ahead. In this one, we're gonna have a quick chat with my friend Tim. Hey Tim,
yeah, glad to be here.
good to see you. All right, cool. So cloud infrastructure has undeniably changed how we write and operate software, but there's an exponential increase in the complexity, and this is basically going to cripple our innovation very soon if we do not really think the tools and systems that we have. In this episode, we're gonna chat together about how adding maybe some intelligence to cloud infrastructure management and operations can take us to the next wave of innovation. So Tim is a managing partner at Essence VC with a decade of experience leading engineering and enterprise infrastructure and open source communities and companies. Tim, you have a lot. You've done a lot in the cloud infrastructure space, and as we were chatting a few days ago, you moved at both sides of the table as an entrepreneur, engineer, and now as a VC. So definitely, we look forward to hearing from you.
Trying to at least, yeah.
All right, cool. So let's start with this. So what is your take right now on the state of the cloud infrastructure? Where do you see the problems and bottlenecks that engineers and companies are facing these days? At either the early stages of just writing code and then deploying it, running it, and maintaining it on cloud infrastructure.
Yeah, well, I mean, right off the bat, that's a huge topic, actually, right? Because when you think about what cloud is, the definition of a cloud, I feel like, has been sort of not really changing, but people's perception and people's how they adopt cloud infrastructure has actually been more and more mature, right? They're more and more actually using the cloud for more things. Like in the past, the people that are using the cloud are mostly going to be startups, right? In the very beginning, they're just using the pure EC2 VMs that just running somewhere in the cloud. And I still have to do everything myself. I SSH into every node. I still have to do, provisioning, figure out how to boot that OS, how to do all the configurations, right? So the cloud providers are getting more and more sophisticated because those they are getting more and more mature. And at the same time, either startups all the way to enterprises are getting so much more comfortable, right? It's a mandate for a lot of people to actually move to the cloud. So it's interesting, like moving to the cloud means so many different things for a lot of people, actually. Moving to the cloud infrastructure is no longer just give me a bunch of VMs to run in the cloud, right? It's actually all around, can I actually be, so cloud native has been like very hot buzzword for a while, right? Which means like, I'm going to be able to write my applications. I'm going to be able to manage my applications, test it, deploy it, and even much more further and sophisticated things that we haven't really got to adopt mainstream yet, which we can always talk about. There's so much and more in between that's moving. Basically, the mindset is moving towards in a way that I can fully sort of run my whole IT in the cloud in some point. The whole development, testing, the whole SDLC and shipping and updating everything in the cloud and leveraging the cloud to do everything for me, from states to releases to everything. So cloud infrastructure is so much more complicated now. It's trying to becoming this big gigantic toolbox for everyone, that I can actually, put my code in there. I can use Lambdas now. I can use, ship containers now. I have Kubernetes as a service, and I have all these different variety of options. And I also have multiple clouds to pick from. So there's a lot of things going on. So there's the infrastructure layer in general, there's applications and everything in between. So this space is just taking off. You know, it's funny to kind of still say cloud infrastructure, that's still moving fast, because it's been 20 years or something like that, right? That cloud has been there, but it still feels like we're in kind of infancy stage, because not every single enterprise is fully on the cloud yet. So that kind of gives you an idea that it's actually pretty complex to really get there. And, you know, since we're on this intelligence topic, I mean, there's a lot of things I think a lot of people really will need. But, you know, we can stop there. I don't know if you're saying particular.
Got it. So let's maybe dig deeper. You know, the main topic is getting complex, right? And getting complex means the steep learning curve, slower progression, and, you know, array of other problems that we may have. But let's zoom a bit deeper and maybe take the major stages of software, you know, development and operations lifecycle. When it comes to writing code, what are the complexities that you see right now that the cloud model introduced, and you know how this is impacting engineers and companies in you know and their ability or their desire to move really faster? Do you think the cloud made us move faster, slower? In what sense? What are the risks there that may actually slow us down the road?
Yeah, I think the cloud definitely has improved a lot of things, but also introduced new complexities now. That it's probably always been a problem, but not as complicated, or not going to be like out of proportionally being a problem. So, you know, like if you're talking about like how people are using the cloud today, right? You know, we're in 2020 now. You know, 2020 is the cloud native days, right? It's no longer just give me 5 VMs and I'm going to SSH into each one of them and try to manage my own, right? This is Kubernetes is becoming like the standard more and more so. Like containers is the way you should ship and deploy. So, you know, I'm trying to fast forward all of that to today, because there's enough to talk about even just today. You know, if you're working on a new sort of like platform or service, you know, regardless or larger or smaller company, if you have the choice to start from fresh, right? Like you have any legacy constraints, you're most likely going to be writing your code, you know, into a Docker container, right? Because that's probably the sort of standard way to ship any code today, right? So I'm going to create a Docker container, and then I have options. You know, once I have my service, I need to think about different things. So I write microservices now. Do I have 5 or 10 of them, right? Do I need to put them into containers into the same cluster? And, you know, do I use Kubernetes or not? And if I choose to use Kubernetes, which is probably the default choice, to be honest, today, you know, there's some other options, but for the most part, people, if you have a fresh new, no legacy strings attached, you're going to probably pick Kubernetes today. And yeah, so there's complexity, because I think people that are getting into the cloud world today is most likely actually learning not just what Amazon EC2 is anymore, and what Amazon's or Google's or Azure's services, right? Because you need to get the basics down, which is what is a VM? How does it work? You know, where do I store my state? How do I even get a machine, right? How do I actually allocate different things that I need, which is like load balancers, you know, my cloud storage, right? There's a storage piece, there's the compute, and there's the networking, and there's everything between, like the security models, all of that. Those are things you have to get in your head first, right? And then the next step is, okay, I'm going to try to do the 2020 cloud native way, which is put into all the containers. I need to learn Docker. I need to learn how to push tag images. I need to learn Kubernetes. You know, Kubernetes has its own suite of all these things. And, you know, I can't treat Kubernetes like I have my VM anymore. I don't even know where I'm going to deploy my app, right? So I need to make sure it's resilient, right? It has HA, it has pods that can move around, right? If it's relying on databases. So there's a lot of complexity on each step you need to actually get ramped up with. And I think that's a lot of complexity actually for a lot of people, you know. So that's one step, is just get closer to even just, you know, what to do to even have something that's functional and closer to how the Kubernetes design was for, which is I want to have applications able to be running in a way that I don't have to care which individual servers they're running on, right? It's a declarative model to be able to say, I want these services. I want to have 5 of them running, and I want it to be reachable by this IP imports, right? And make sure that everything between anything that can fail, I have sort of a backup for. There's sort of that concept that needs to be tested and all the things between. So I think, that's definitely the number one thing to think about, just learning all those.
Absolutely. Now, that you actually implied an interesting point, and let me also get your thoughts on that, which is the complexity for the DevOps versus the complexity for the developers. Which one of these you see actually most hit by that complexity that we're referring to?
It's a complicated issue because, to be honest, developers and DevOps used to be, DevOps are trying to get closer like a developer, right? It used to be, we call them, system engineers, right? People that really look after systems, and their only job is to keep the cluster running, right? And developers, you have more defined, smaller roles, but because things move faster that way. So the DevOps movement was trying to make everything much more faster, try to move operations like a developer, building the toolings, building the automation, like all of that happening. So now, like, developers and DevOps, like, they're in some way they're not that different. In some ways, that you're also trying to build a lot of toolings to help to operate. It's the larger company you are, the reality is that you're more likely going to have more separation of concerns. That I'm more likely going to be throwing my application code to the other side, call it DevOps, right? If you're in that situation where I can really just pick my code, ship it to somewhere else, and I don't really deal with it that much, then I think the SREs will have a maybe tougher time in the beginning because operating all these new things is quite complicated. You have to learn a lot of new concepts, learn a lot of new things that can fail. And it's moving fast. Like Kubernetes up their versions every three months or so. Docker is upping their versions all the time. And there's all these tools in between that you're using that's changing rapidly. So it's not a stale, I learned one tool and I can good for a year or two, like you're just like really learning a lot of things. And that is not easy for a lot of SREs because you have to learn all of that in a sort of rapid manner. Otherwise you feel like you're left behind because those tools are moving away so fast. Developers, it's not like they have the easiest time. They might be a little bit easier, but it's still a jump between knowing how to write my app into containers. Like I still need to learn about what a container is. I can't just hard code IPs anymore. Right? I can't hard code host names anymore. Like it's no longer the things I'm used to doing. Is not that easy. I didn't really separate a lot of concerns and do all that. I think there's probably more ways you can sort of go by doing some simple things as a developer. But SREs, you want to make sure things are running all the time and also make sure that it's running smoothly too. So you have a lot more burdens on your hands to make sure it's actually really smooth sailing. And security, all that is really hard. Right. So I think SREs will probably have a harder time in general.
Absolutely. And I could see this actually from my own personal experience. Now, if we maybe focus a bit on the interaction dynamics between the dev and SREs. Yeah, now the SREs, they have more to manage. And I guess the developers with the now almost more than a decade DevOps movement, that developers need also to stick their hands more into the infrastructure.
Yeah.
How do you see the dynamics actually moving forward right now? Let's take a snapshot of, what's your perspective right now on that and the interaction dynamics between the DevOps and SREs moving forward, if we just continue with the same way we are right now.
There's always this running joke between software industries and even VCs, like there's always this, it's like a trend that keeps going back and forth. There's the bundling effect, right?
Mhm.
and the unbundling effect, right? You know, and that trend will keep going back and forth, right? Things used to be unbundled. There's going to be some way to try to bundle them all together because they feel the pain of unbundled. And once it's bundled, you have the pain of unbundling. And Dev and DevOps are kind of in that way to me, because I feel like in the beginning of the whole Kubernetes cloud native, because I think in some way cloud infra now is really cloud native. It's been sort of the default trend, at least, unless you have legacy concerns or legacy infra. A lot of people are basically going through Kubernetes. And if you're in that train and you're just getting started, you're most likely not going to say, DevOps, go learn it yourself, devs, go learn it yourself, and let's meet once in 6 months, figure out what we learn. They're most likely going to be partnering together in the beginning, because it's hard to separate devs and DevOps if you're using all of these tools together, because you need to develop your tools with Kubernetes in mind, right? You have to map your code, you have to map the things you write, and also how you're going to run all your dependent services into Kubernetes, and also figure out like, oh, does that fit? How do we actually, figure out load balancing, service discovery, right? Security is all that stuff that my application needs to be figured out as well. So I've been seeing a lot of DevOps and devs are sitting with each other very closely in the beginning, just to try to figure everything out. And that's kind of a partnering journey you kind of have to make. Like Dev and DevOps isn't that far away. You kind of have to be really close partner, just because there's so much complexity in this whole journey. But of course, when things mature, right, which is what we see in the sort of VMware days, is like, yeah, I have a team, is running fine. I'm mostly just making sure things are running, great, and might add some additional tooling, but it's not like I'm replatforming every 3 months or so, or 6 months or so. So that is probably going to be, I think we're probably going to get to a stage, Kubernetes becoming a lot more stable for a lot of people, and a lot more sort of like everyone kind of learn how to run the cloud native shop from a sort of system management into all the applications. But right now, I feel like it's still in the early days, right? So they're sitting closer than ever. Like usually I see in larger companies, you have your sort of IT team, and that's managing all the infrastructure in IT. But they usually partner developers and a new DevOps team, right? Just to be able to figure all this out. So that has been a very consistent pattern so far. It's like this greenfield Kubernetes thing. We're going to have a brand new initiative and try to collaborate and go from there. So I think it's never going to be a straight fixed line. It's going to keep swinging back and forth for the most part. But I think the reality is, the larger you are, developers want to care less about infra. That is probably true. That if I'm running front ends, I don't want to learn Kubernetes like at all. Like the less I can do, the better I feel like it's more easier on my side. Right? And a lot of developers in larger companies do have that mindset. Basically, just stay in my lane.
A friend of mine actually at 500 startups was joking about that. And when I was explaining to him Kubernetes and cloud native and things, how that technology is trying to help engineers and companies to move faster. And he's telling me it's just like deja vu. We've been going through that cycles since the 80s and 90s, right? Mainframes, desktops, server client architecture, and then the cloud. And it's all about just trying to save money, move faster, decouple things, as you said, and we're still doing that again. Why do you think that we're just going through that pattern over and over again, rather than figuring out just completely a different model that would just solve some of those problems, from the get-go?
I think it's just software is just not, there's different fields in this world where like it's very complex, but doesn't change every year. Like if you're a doctor, you're not like learning, oh, humans have evolution now. Last year from this year, it changes like 50%. Let's all go relearn how does the body work? Like there's a lot of mystery still, right? But you're not like just changing all the time. Like software by a default, like it's been built on foundations that basically is a rapid changing field altogether in the first place. Every standard we have, I mean, there's IPs, TCP IP, all this stuff that we built the foundation of that's not changing that much, but it could still be changed. So we're in this we're in this space where just complexity, it's built a lot of things that has not really foresee all the complexity that we had in the future. We have a lot more servers, we have a lot more data, we have a lot more, budgets, we have a lot more everything now. Like it's been designed with one sort of frame of mind, but that frame of mind quickly breaks in a couple of years. So we're just redoing all of this, and that's why we see companies like Google, right, Microsoft. Like in some ways, Google has been living out the future, right? For sort of see. They've seen the complexity, seen the sort of the scale. So they've adopted a way that's kind of like what we call the containers way, right? Or, Facebook, a lot of these companies, if you've seen, all of them had kind of moved to containers like 10 years ago. So we're kind of living out that journey where complexity is still growing the same way we're looking at, like the amount of data, the amount of application. We never had microservices before. We never had a startup running 50 services, right? We always, it's that complexity just keep growing all the time, and the amount of data we need. Everyone's using AI now. Everyone's doing some kind of AI ML. Or it seems like every startup will soon just be running some kind of AI stuff too. Like that complexity will just keep growing. So I think that's a matter of fact, like the needs of our apps and the needs of everything else beneath that is just changing every year or so. So, we're breaking new grounds all the time. It's just too hard to have one thing that
makes sense. And actually, that's a really nice perspective. Now, since you mentioned the future, let's talk a bit about okay, we talked about the complexities.
Yeah.
What are your take in terms of what should we do? How can we really, what are the different ways for startups, innovators, engineers and companies that can work some of that complexities? There's some, of course, short-term practical stuff that we can do right now, as understood, but let's just think even beyond that. How should we really rethink our toolings, rethink how infrastructure is being run, provisioned, and so on? And of course, we want to also touch on the software development part, if you see any relevance.
Yeah, so you're talking more like just how do we handle complexity of adopting cloud native overall, or?
That's either in the adoption or in just understanding the model, right? It doesn't have to be specific to that, unless you see this as the biggest risk at this moment. Whatever you see relevant.
I think it's certainly complicated because the toolings move quite fast. What we view as a standard today, it probably can change and will change next year. So I think the reality is just going to be like everyone has to sort of actually, everyone's journey to cloud native, therefore, is very different, because maybe I do have a lot more on with stake, like have a lot of live production users. I can't just change things that easily, or I have 50 to 100 teams, or I have a lot of interesting different requirements. Like everyone's journey will differ quite a bit, just because that is your constraints that you're playing with. So I think everyone has to start somewhere. Basically, I think if you look at this as a big complexity and I want to eat them all, you're never going to really able to do it successfully. So you're going to have to start piecemeal at a time, and everyone's going to pick different places, I think. But containerizing your software, your apps, is usually the first place for everyone. So I think that you kind of have to take like one layer at a time. You don't want to take a big change, right? Because how do I actually get my apps to just run in containers, right? That's already a big change for a lot of folks, right? And by default, that means I can start to break apart some big applications that really hard, that has really bad characteristics when things just fail, right? So I need to break into smaller services. You kind of do one step at a time, and we're just talking about like really the basics, right? We haven't really got to like, what any sort of like ways to even help it to be run or develop much more faster or smoother. But I think complexity, I don't, it's really, I don't want to give out the device where like, okay, to deal with complexity, adopt these three tools,
Yeah,
think about these three ways, because
but
everyone's complexity is so different,
yeah,
and we just have to take one step at a time. And I think the easiest way to always been, yeah, think about one problem you want to solve with the new toolings that has been one of your big bottlenecks, right? That you
got
can
it.
actually see a win and start from there, right? Yeah.
Got it. If we maybe try to think a bit differently and see if we can use something like the AI, right, to help us solve those problems. And I know that each company or each team will have, its own complexities.
Mm-hmm.
But there are some sort of an overarching or kind of patterns or
Yeah.
some sort of problems that are generic enough that can be solved with tools that can help everyone move faster.
Yeah.
Help the engineers to move faster in general in their journey, either to be cloud native or either writing just at the initial stages of writing their code and making it more resilient, more cloud native kind of ready.
Yeah.
Uh, any thoughts on that?
Yeah. Well, there's so much to do, even if before we touch AI. I feel like,
Uh-huh.
because I think the reality is all the tools are so nascent today. Like Kubernetes are still a fast moving piece of software, and all the ways people develop, operate, and manage are still like, if you look at the default Kubernetes dashboards that they have, right? It's showing you information, but not really showing you like the crucial information that you need at the moment, right?
Mhm.
So there's you just that, and that's what's shipped by default, right? And so any tool takes a while to really mature and takes a while to even figure out like what is the ways to help people, because I think like I'm super excited about AI. Hyperpilot, the company I started,
Mhm.
we were putting a machine learning into sort of infrastructure and Kubernetes as well. And that is, I can see that as a superpower, like a superpower that you can add on top of any sort of problem. But at the same time, any superpower comes with responsibility. In some way, it doesn't solve all problems. It also actually can introduce new problems.
Mhm.
If we talk about AI in general, like AI is also a very, still we consider like early field, right? It's been there since the 70s and 60s, but new techniques and new ways to do AI has been changing, right? Deep learning is the biggest new sort of trend, right? And deep learning is just affecting everything. It's affecting not just applications and services, it's affecting the AI research, right? Now you can put deep learning into all the traditional ML methods to make them go faster and better. But the whole point of that deep learning is all about like, how do I able to not have to think of all the predictable patterns myself. In some ways, I can actually have a lot, if I have a lot of data to train, I can automatically figure out the patterns and have a much better accuracy here. But, any AI, there's always the issue of trust and any issue of accuracy, right? And accuracy comes with trust, basically. It's not always right.
Yeah,
you
yeah,
know, you
absolutely.
know,
Yeah,
I
I would
have
like,
some accuracy number, 80 or 90%, right? That's considered great, right?
yeah, I would like actually to dig into that part. But if we first, dig deeper into the solution, piece. So it's interesting that you try to use AI to optimize the performance,
Mhm.
right, and certain configurations of infrastructure and apps running on top of it.
Yeah.
Now, this is definitely an interesting area, and as you said, it's basically trying to cover where there are lots of possibilities, and I cannot really run through all of this, and I need to get the answer very quickly in a reliable enough way.
Yeah.
What are the other areas that you think the AI, can be applied to? It has also the same kind of, problem attributes in the infrastructure space or in software development for cloud infrastructure.
That, well, I think, there's the famous Mark Andreessen, software is eating the world, right?
Yep.
you know, I think this has been said before. I mean, Andrew Ng or somebody, right? It's like AI is basically eating the world too, right? And I think AI is slowly eating the infrastructure world as well. Like if you talk about like what problems, I feel like every problem could be AI, you know, possibly with an AI solution. But you can't just cookie cut it, like just throw the same model everywhere to solve every single problem. And that's because the infrastructure has always been one harder place to apply AI, is because infrastructure is by default needs to be stable. You know, if I'm building my applications on top of your platform and it only works 80% of the time, you know, then either me as a person depending on your application, your platform needs to figure out how do I mitigate that 80%, 20% failure myself, which is a lot of times what cloud is causing people to rethink their applications. But big part of cloud native is like my machine will fail anytime. My container can die anytime, right? Therefore, we built in a lot of these patterns, like, you know, like stateful sets, you know, and load balancer between different things, health checking everywhere, right? Migration, this and that. It's just because we know that by default, the infrastructure is not going to be up all the time, right? And also AI comes in, you know, and like there's so many problems. Like we can narrate every single problem that you see in infra, and we see it every stack and every layer. There has been people researching all kinds of stuff to put AI, all the way from your networking, your storage, you know, every flash controller you have on your computer, CPU, figuring out which cores to run, scheduling, you know, this and that, picking what configurations to even configure on your kernel, you know, and picking every configuration you need on your stack everywhere. And how do I route my network across my data centers? You know, everything between, you know, like there's the AI you can put in everything. Because anytime you have like a complexity and a choice and some probability, you can probably apply AI, you know, basically. You know, and there's definitely more and more vendors. Well, AI is in every startup pitch I see so far, so you know, it has been consistent. There's a lot of vendors are putting AI into their software stacks now. That's in the infrastructure families. Like one example I think of right away is like Harness, right? You're doing a CI/CD, and one big part of your pitch is like, we have AI. You know, the way we apply AI, because if you know what CI/CD is, right? It's me anytime I update my code. Right, I go through like a rigorous test pipeline, which is running all my tests, and I immediately go deploy it somewhere. Right, I don't have to wait. You know, maybe there might be a manual gates, but for the most part, CD really means go straight to production sometimes. But at least to staging. You know, a lot more people not yet to go to CD, but you know that's probably the future. Right, it's go straight into production. And how they use AI is basically trying to figure out like my new version versus the old version, right? Does it really give me any statistical differences in terms of like the performance metrics that I care about? Like that version has been seen for the last part of that traffic is deviating from the standard deviation now, you know, from my P90 latency. So maybe I should consider rolling back to my last version, right? You know, some sort of way to learn how does each version has impacted things. Because there's learning in different ways. There's learning about the metrics that you're exposing throughout your applications and everything in between. Or there's even like, I kind of lose a little train of thought, but there's a lot of complexity when it comes to like just knowing how to read metrics overall. And how do I understand what is the changes that impacted. So there's, AI can be everywhere now.
Yeah, I agree. I mean, you can definitely apply AI in so many different places. And I think you also mentioned the criteria. If there's any kind of probabilistic, you know, kind of decision making on top of matrix or some basic stats, you can plug AI in that area. But if we even just abstract this part or forget about, you know, where AI can be applied specifically, where are the areas that you think that are presenting now as most bottlenecks in the space? And then maybe we can say, oh, okay, maybe there might be an AI for that, or maybe we can solve it in a different way. What is the biggest bottleneck? What is the biggest problem that you see from your point of view?
I think I think actually AI can really solve a lot of problems, to be honest. But it's just like is it really the sort of like top of mind problem for you? And are you willing to spend a lot of time and energy to solve that? Because AI takes time to train, takes time to prove, and it takes time to kind of come up with a strategy to figure out how to make that work. But one thing I really, the problems that we worked on Hyperpilot was pretty interesting in a way that, you know, there's one thing I definitely thought about right away is like, hey, it's so hard to configure all the things you use, from the software you use, the hardware you use, everything. Like there's a lot of choices that we actually don't bother choosing at all. If you think about it, like a very normal stack people write today we're probably going to be like, I don't know, pick a Node.js server, right? Running a front end, right? And an application, and that's connected to the database called Postgres, right? Right. And, for the most part, most people, what they do is they found some default thing, they found a default configuration they find online, right? Or somebody might have tuned something in the last year or two. You use it and ship it, and if you think about like all the choices you are ignoring and all the choices you kind of by default are just using for, you don't even know why, are all the way to what instance types have you picked, and what is the sort of all the numbers you picked in between your Node.js server configurations, your Postgres configurations, like what Kubernetes configurations has you picked? Is it going to be, 3 CPUs, 2 gig of memory? Is it 5 CPUs, 4 gig of memory? Is it 5 containers, 3 containers by default? If you have autoscaler group, when should it autoscale? It should autoscale when 30% CPU, 60% CPU. There's a lot of numbers and choices. And to me, what I think AI obviously is applied everywhere. But what I like about the configuration part of things is that, there's so much low hanging fruit that if you usually configure a few things, it changes your performance really 2-3x by default, at least sometimes. And that to me really, and we see a lot of these examples, like people tuning JVMs, people tuning Postgres, right? We don't really bother tuning because there's maybe some effect like, it's good enough. Sometimes it's good enough to start with. So that's fine. It's like, using defaults is doesn't crash and burn all the time. But there's always going to be like an inflection point. And, people always kind of wait until like, wow, why have I been buying so many servers? Or why am I just getting so bad of a performance? What should I do? And, the only thing people know is just use a new programming language, use a new framework. Don't even bother tuning the first one. Like, I think there's actually AI can help quite a bit because it's very complex. Human can really model every single tunable knobs here. So you might as well, consider actually use some way to tune your software automatically, because it actually has a huge impact in terms of like your cost and performance actually. And that to me has been, a very sort of like entry into sort of getting AI to tune your infra, because that to me is can make a huge difference that your human just cannot do. It's not even a manually, I mean, it's possible, but you kind of search so many different things, right? so that is actually one good place. I feel like AI can be really powerful, right? Because it gives you immediate results. And actually there's not much to lose too. Because once you have a good enough way to just say, okay, is this new software works or not? It does, and actually improves quite a bit. It should just work, yeah.
Got it. So I'm curious to know actually your personal story behind that. How did you come up with that that possible solution, and and decided at the end to found Hyperpilot? Did you go did you go through some experience that made you think about that that problem and the solution for it using AI?
It's this has been in any system research sort of conference, This has been a research topic for decades, right? So it's nothing new. Like it's really nothing new. Like there's a lot of pre-existing sort of like literature around these kind of things. It's just, it's always so specific, you know? Like it either, you know, it's a big company like Microsoft coming with a paper. I'm tuning very specific thing into specific scenario, or I'm doing this and that. I think it's just been the complexity to, there's just way too hard to even employ something like this because it's been written all over like a math, you know, it's a lot of math,
Yeah.
you know, and there's no pre-existing libraries. People actually are spending time to build all this. So yeah, you know, it all comes from system research, really. My co-founder is a Stanford professor. So he's been in this research area for a while. And, you know, I met him at Mesosphere. He was our director of research. And he was actually looking at this, how to bring a lot of things he built in Stanford into sort of this whole software infrastructure world. So that kind of gave me exposure as well. But yeah, it's definitely nothing new. I think it's just like the matter of how do we really know how to take a lot of these sort of research ideas and make it into a production ready software is really hard because there's two sides of the world you really need to know quite well, right? So, you know, the research side, the math, statistics, the ML, plus the systems, right? Because if you cannot reliably deploy this in production, and trust it won't crash and burn someone, you know, nobody will ever want to try this, right?
Absolutely. Yeah.
So that's like a very hard combination for anyone to really bring together.
Yeah. One of my professors actually during my PhD told me that research is in computer science and engineering is roughly 5 to 7 years ahead of the industry. And again, I think the reasons that you just mentioned are the ones that basically making academia a bit ahead of the industry. It's really ideas and research might look actually lucrative and they may look applicable once you bring them into the reality of complex systems running in cloud infrastructure. It's a really much harder problem to apply them. But once you apply them, definitely the gains are huge. The ROI is huge.
Yeah.
Now, if let's now assume that AI got used in some of those systems, where do you think, if we just try to also project the dynamics between the DevOps, the developers, and maybe other roles in the organization or within the team, how would the AI actually make things easier or more complex or faster? You know, what do you envision there?
Yeah. Yeah, it's always fun to kind of like, hey, what would 2025, 2030, you know, it's like going to Disney in a we're little, right? There's like this futuristic, right?
Sure, why not?
Like Florida, Disneyland, right? There's like this futuristic, what would imagine people live like, you know? Like,
well, here's the reason for asking this question. The reason is, now we see that, you know, every time the technology becomes more and more complex, there are more and more kind of human interaction that is needed in that case. And the whole idea, the whole premise of technology is to make us more productive. And part of being productive is, being in sync together on the same page, moving at fast-paced, in terms of developing applications and running them. But not being crippled by the slowest person, or not being crippled by having those gaps or discrepancies between different team members. So I wonder if AI actually would have a contribution to that. If AI would allow us to, move faster as humans, right? In terms of our interactions and in terms of our understanding of the reality and making some progress there. That's what I'm referring to more than, something really far ahead in the future. It could be more on how do you envision the role of the AI, or what is the right way from your perspective? We should roll out the AI inside teams and organizations to make some of those problems, less severe.
So if you look at how people are employing AI in the infra world today, I think the most obvious and probably the easiest place that people are applying it right now is on your monitoring data. Like there's so much monitoring data, dashboards and stats from everything, right? So if you go talk to sort of any enterprises, they're probably already playing with some idea, actually, of just trying to just do some sort of simple
Yep.
way to just sift through the noise, and like alert fatigue, whatever these people, there's a lot of sort of problems people kind of describe um, that infra people are facing. It's just like there's a lot of complexity, yes, but the harder part is just like there's just so much noise that coming from these systems. There's logs and numbers from everything in underneath your app. Like it's just way too much data. Just even looking at logs is impossible, right? But logs is just such a small number of things that's available. Like your whole OS just dumps out millions of data points potentially for you to able to observe. Like, what do you do? Like, you have like so many clusters, you have so many apps, you have so many layers in between. They all can give you all kinds of numbers and things and signals, and just way too much data. Like that picking a problem that human just cannot even do well, right? But have a lot of potential is usually a good place to start, because replacing humans is going to be a very hard job, and I don't think it will be possible, right? I think replacing low-hanging fruits, like really low labor, not going to, really hard to make mistakes, sort of low-hanging, repeatable tasks,
Yep.
is one good thing AI can do quite well. And trying to sift through the noise, because just way too much and not even humanly possible to be able to parse it easily, are two good places to start. And monitoring data has definitely been one thing. I think that's definitely has been what trend. If you look at any IT monitoring system like Datadog or any vendors out there, they've been introducing this idea like, I'm going to give you some kind of AI. I'm going to give you like the way to give you a prediction. Like, hey, if you keep, this lines going up this way, I think you might end up in a state where your memory leak is way too high now. You're going to actually crash and burn at some point. Or the last alerts that happened, what is the last thing that happened in your system that most correlated to that problem, and try to figure out that out as well. So like just trying to like find the sort of the signal that really matters. It has been one of the most probably easiest and pretty impactful, but still not, I won't say it's easy, actually really hard, because there's so much data. So people really just pick and choose the vertical, and pick and choose some number of metrics and really try to do that well. But you still can't trust it 100% of the time. So,
Yeah.
at the end of the day, human is always involved, like,
Yeah.
and designing human to be part of that process as much as possible is going to be pretty important. So I think that is definitely one big place that AI has been really been introduced in the infra world completely.
I think you're definitely referring to the AI ops in general. How can I use AI to simplify my operations? And it comes mainly into monitoring and handling, life site incidents. And one of the things that I personally noticed that I see the contention usually goes up between developers and Devops when in such life site incidents, by just trying to figure out where's the problem, right? Is it an infrastructure problem, resources problem? Is it an application problem? Is it a bug? Is it an expected behavior? And just trying to distill that and trying to understand what is going on sometimes creates a lot of contention, either during the life site incident or in the postmortems that you go through after that.
Yeah.
And if the AI can apply it in a way that would help those roles or teams to work more in harmony, and it's easy for them to figure this out, I see definitely a boost in the team's productivity if done right. So that's why sometimes when I personally, when I think of the AI, I don't only think of, well, how can we just make things faster and whatever the metric that you have in mind, but it's also about the interaction between engineers, and is it really helping us to have a more fulfilling job? Are we really feeling that we're making progress in general or not?
Yeah.
So the role of the AI, I hope that as we are building the next generation of tools and systems that we use, hopefully AI or any other kind of technology, is to consider that factor, because that's important, right?
Yeah,
Now
sure.
we're able to move much faster on the cloud, but are we really having, the work-life harmony or balance that many speak about, right?
Yeah,
It's now much tougher than before, especially these
yeah,
days
yeah.
as all of us working from home. So it's important that the human factor is really important. So I'm not sure if you have any thoughts on that.
You know, when you're talking all this, actually, I feel like it's actually what really interesting to talk about, you know, is like what a future AI ops will look like, actually. Because I think that to me is very intriguing, because I don't think we actually have seen it played out. We're truly in the earliest infancy of AI ops, right?
Mhm.
Like people don't even know what AI ops really is for the most part.
Yeah.
We kind of all we know right now is like there's some AI and monitoring data, and they're telling us, giving some suggestions, right? That's like kind of the only understood parts for the most of IT industry right now. And that's just really scratching the surface, I feel like.
Yeah.
Like when we talk about like what the future, if we want to go there a little bit, because I think that was super interesting, is like what does the future AI ops can look like?
Mhm.
I think there's a huge opportunity. And I mean, timing is debatable,
Yeah.
obviously, but if we forget about timing, like what does AI can do in this whole IT world? I think we're gonna see at some points, AI is not just giving you suggestions. AI is actually gonna give you actionable things that actually will change the behavior of your clusters and start to work all the way back. Because right now AI is being applied sort of in the end. I already configured everything manually. I already deployed every application manually. I've gone through all the things and it's running, right?
Mhm.
Now I use AI to kind of tell me bits and pieces of information of what I can do. It's going to start playing back because besides just giving you recommendations, it's going to actually act on that. It's going to go change something. It's going to go do something for you. But I think before you even get there, it's going to go creep down into sort of more and more systems, and how do we actually automatically do a lot more sort of experiments in our clusters for you. One thing I definitely see, like LinkedIn, Facebook, and Google, a lot of these sort of like larger players have been doing is, hey, I have a hard time tuning everything, manually tuning everything. So can I run experiments in production, run 5 versions of the same software, configured differently, but all have the same traffic kind of like teed into multiple of the same replicas, and just see how they behave, and only one of them is actually a true application, but you just kind of just observe the behavior, just by copying traffic and copying the same app, but just tuning different things. And you can apply this to anything, right? You can apply this to your JVM tunings, your database tunings, different instance types. You can actually run experiments in production through AI, because AI can help you in a lot of different ways. It can actually give you the sort of like most optimal suggestions. So you don't have to actually try, you have to try huge snowflake of choices, right? Can I actually just try 5% of choices to make sort of near optimal suggestions? And so, we're going to see like, I think we're going to get to a point where AI is going to run, there's already the concept called chaos engineering, right?
Yep.
Which is like, we're going to run failure in production. We're going to unplug your power plugs in production and kind of just see what happens, right? And they call them just controlled experiments, which is like, I'm going to try to make sure I'm just only introduce a little bit of failure, and I have this blast radius boundary set up so it doesn't try to kill everything, but I'm going to make sure that it still works. And the reason why I'm doing it in production, because it's the only representation that's close enough to what actually going to happen in production. It's really hard to replicate, do some synthetic data and traffic. It doesn't really represent the real world. We're going to see a lot more tuning experiments as well.
Yeah.
That's going to happen. That we're going to run 4 or 5, experiments and see which one sticks. All the way then, we're actually going to see AI controllers able to just changing things on real time in your systems for you. It's going to actually able to route traffic's realistic, it's going to able to create more containers, or changed all different ways, operating system has been behaving this and that based on different scenarios and situations, right?
Got it. Now, last part, let me just ask you to wear your VC hat, and
Yeah.
let's just talk a bit about the startup world in general. So, what is your take in terms of the startups that you see in that space? And um, we talked obviously in an abstract way about areas that are promising, but do you see now startups in that are emerging to maybe solve some of those problems using AI? Do you have a general kind of advice to entrepreneurs and innovators in the space just to pursue, or solve those problems in a more practical way without going too much into just daydreams or, over indexing on AI?
Yeah, I mean, that is hard, you know. Yeah, I mean, with with a VC hat on, this has actually always been a struggle, um, from an investor point of view, because I think a lot of technology is great, right? It can actually has a lot of impact, but it's sometimes really hard to understand. Like, technology on its own can be good and bad sometimes. Like, it can actually cause some harm, and or cause a lot of confusion, because software is not never perfect, right? It's like, yeah, if I have a software that can automatically save you 50% of your money with no changes at all and just flip a switch, right? Everyone will flip that switch. It's like, if I can lose my fats, in 5% just by doing one thing, it has no side effects, no sort of like price point, nothing. Everyone would make that choice, right? There's always a trade-off, and that is, I think a lot of teams don't sometimes understand what that trade-off is. They only think about things from a technical point of view. That if you trust me enough, I trust my ability, I trust my background, I trust that I can solve any problem I see, um, from a technical point of view. But they don't really understand, like, businesses don't view technology that way, right? Businesses don't look at new shiny techniques to do a lot of these fancy things. They see it as a risk all the time, especially if we go to infrastructure. Everything is a risk. Any change is a risk. Like, actually, any new version of your code is a risk already. Like, let alone like doing anything crazy. Like, risk management is just by default one job of any SRE is trying to make sure they're doing is to make sure things doesn't fail, because I have SLAs, I have responsibilities, I have a salary I want to keep. I don't keep. I want to get fired for these kind of introducing some bad things and just not thinking clearly. So I think technology, one challenge for anybody who wants to apply AI in any infra is to have the ability to really think through the customers' shoes really deeply, to be really able to know who they are and how they think and how they view your product and your solution in their shoes in a much more intimate way. Because I think it's a really hard space for, like, this is a lot of systems ML. It's not like, this is not a, just take my simple scikit-learn and just apply it to my data. It's actually a really hard field because you have to do a lot of things. So it tends to be, the people that are attacking this space tend to be more of the research or the very sort of technically inclined founders. But at the same time, they have the least amount of experience sitting in, a Fortune 500 SRE or head of infra shoes. That world is just completely different. They're thinking about not getting fired.
Yeah.
They're thinking about, just doing a minimum enough to just make sure I don't cause chaos, right? And so that's this tension that any startup needs to figure out. Like, how do I talk about my product? How do I introduce my product? How do I make it work and look like it's not really going to cause problems? Because AI is not going to be 100% accurate all the time. So, like, what problem can I start? How do I really build and sell something that seems like, it's solving a huge pain point, right? It's a top of mind problem, but that doesn't cause big, crazy failures. And how do you guarantee that, right? Because people are not going to take chances.
Yeah,
so there's this big problem. I think any company that wants to get into this space is just how to figure out like, and I think that the ways to mitigate that are really, you kind of have to solve a problem, a very specific problem. Like even say my AI is going to solve every problem for you, like every IT and performance problem or every IT cost problem, or that's not going to fly.
Yeah.
You really have to solve a specific problem because you have to have a very specific way to mitigate risk for them. You know,
Yep.
if it goes south, do you have data that's even available to tell you that in a very quick way? You know, because one of the things I learned is trying to go through hyperpilot journey is that most people monitoring systems isn't that reliable, you know, and is not accurate too. And doesn't, people don't give you like a sub-second accuracy, even like intervals. Like it's usually been like minutes. So what happens? Things fail in between. Like you don't know it's, or you know, and you react too slowly. There's a lot of different failure patterns in between. So unless you can really control the environments, it's really hard to make things do the right job. So I've been more excited about systems that are kind of in a closed, in a more managed way. Let's say.
Mm-hmm.
So not like AI system just plugs into your existing and just crazily able to know everything. That's the future.
Yeah.
Maybe we'll get there. The best and easiest way is like, don't even think about I have AI like at all. I'm gonna run something for you. Like I'm a managed SaaS, or I'm a managed PaaS, or I'm a platform that can run something for you, or some workload, or some exact task for you. But I'm gonna manage from everything end to end. So if it fails, it's my responsibility to fix it, not yours, right? Then I feel at least you're on the hook. Yeah, I'm not on the hook, right? And that I feel more comfortable, you know, at least trying it, right? Not maybe complete trusting it, but at least trying it, because you're on the hook. You got to make sure everything you do say there, it works. And that's good. I feel like it's probably easier way to get people to be trusting AI in general is that you kind of have a full end-to-end experience and you're hiding AI to help you do that platform and help you do that job much better and easier. Instead of saying like, hey, AI put into, you know, it's like, I don't know, some crazy solution to put into water is just going to fix everything.
Yeah, absolutely.
You know, it doesn't work that way, you know? So that's actually one of the hardest part is just like, how do you get human in the loop faster, right? Do you have a reliable system, or can you design a way to sell this that they don't even care it's AI, right? I don't even care it's AI behind it. All I know is you're running this for me in 10x faster and 10x cheaper, right?
Yeah, absolutely. And maybe that we can close with a small story. I tried also to do the same thing for cloud infrastructure, but also I faced the same, risk adverse, teams and engineers, and completely understandable. So what I did, I interviewed actually a Tesla owner. And because Tesla actually has been talking about the autopilot, right? It's the same thing. You give the machine learning or the AI control of your car and your life, right? If it's running on the highway. And I asked my friend, when did you really start running for the first time the autopilot? What did you do? What kind of risk did you have in mind that you wanted to really make sure that the worst scenario would not happen? And he told me I started using the autopilot 2 years after owning the Tesla car. That's number one. So it took him really a while to do that. And then he said, I'm not going to use it while my family with me in the car. I'm not going to use it while on the highway. And he said the first time he used it when he was at the Canadian borders and bumper to bumper, kind of long queue, and then he used AI. So if you think of it, it was a low risk situation. So what's the worst case? It's going to just bump in the front of the person in front of him. He can stop it really quickly. He has full control, right? And if it just misbehaves, it's not much that can be lost. So this is important for anyone who is trying to really think of the AI. As you also mentioned, it's important to be focused, but at the same time, de-risk it for your users as much as you can. Even with a company that is with a ton of resources, large teams in AI, and they have way more data than anyone on the planet right now in terms of training data for the AI. But still, people are not feeling comfortable, using it in high risk situations.
Yeah. I mean, this happens anywhere you have trust. You need to have trust to the platform, right? There's always going to be people that are willing to try it first, and people that are not wait until everyone else has tried it, right? And even when it comes like the cloud, right? In the early days of cloud, people not even want to run anything, sensitive at all in a cloud, or trust your vendors to take all your data. But hey, it become an industry norm. Like, hey, if those 5 people already trusted it, like, makes no sense I don't, right? So maybe there will be a point where everyone just uses Tesla autopilots, or at least some kind of autopilot by default. Like, I'll be dumb not to, right? Or if I'm gonna be the one that fail, lots of other people will fail with me, right? And so there's gonna be some effects of like that.
There's a lot of psychological complexities that need to be definitely addressed. Well, cool. Thank you very much, Tim. Really appreciate it. Appreciate all the inputs and your perspective on cloud infrastructure, how AI can be used, the dynamics between DevOps and developers. That was really interesting perspective.
Yeah, cool. For sure.
Appreciate it.
Hi everyone. Thank you very much for watching. Appreciate your time. Wanted to share with you something quick. I'm working on an exciting new book about the use of the AI in software development and operations, which is going to come out by the end of the year. To make the book as powerful as we can, I'm interviewing industry experts to share their stories, give their experiences and advice. If you would like your story to be included in the book, please click on the link below. You can also sign up to get regular updates and an early version of the book when it's published. Thank you again for watching. I'll see you again in a new episode of Looking Ahead. If you like what you saw, please click on like and subscribe to the channel. I'll see you sometime soon.